Hi, my name is Stephen Choban, and I designed the software which I call SCADTS. Uh, this refers to um, different aspects of modeling, and that is simulation, control, design, training, and effectively a server. The um, the core software, it started out as an exercise to develop a solution using object-oriented design to a solution to a set of differential equations based on conservation equations for fluid systems. And then I thought about the idea of how to store the information, and what came to mind was using a relational database. So I selected MySQL, free and available through XAMPP, and then based the solution on accessing information from the database and writing to the database using SQL queries. The the solution within PipeSafe is based on two components, one being an incompressible fluid and the other one being a compressible fluid that obeys ideal gas equations. Those two components are available within all pipes. In general, let's say you have an incompressible fluid like water. In a subcooled state, it won't change state, so the ideal gas equation won't be applied. It's when you want to simulate an ideal gas like air, then the system has the ability to just transform the equation set for a compressible ideal gas fluid. The next part of the core development was to include single and multi-port devices. So in the case of single port devices, we're talking about valves and pumps, and in the case of and heat exchangers. In the case of multi-port devices, then we have again valves where we have multiple ports, particularly in hydraulic design. You have the case of multiple ports, two solenoids, 3 ports, 4 ports. Following that was to include different fluids and different gas types. And then you run into the question of do we account for saturated and superheat conditions? So for the different types of fluids, I included tables for R134A and R410A, and also steam tables. So water has all the steam tables in there, so that then the solution can include the subcooled, saturated, and superheat states, say for water and steam. So that's basically it. Then following that was to extend the solution to electrical schematics. And since the solution for fluids is a linearized form of the differential equations, it follows that there's a numerical comparison between electrical circuits and fluid circuits. The devices are, and the application to devices is significant, but I'll go into that in a later time. And just in the case of electrical distribution, we can simulate multiple phases, and so you know, using that approach for a reactance representing the system as representing the resistance and DC circuits as well. The relational database is the critical part of this, particularly for access by third-party vendors. Well, first of all, I'll just refer to the types of objects that for which the state is stored in the relational database. So the circuits are generally divided up into nodes and links. The nodes have a volume associated with it, which is more significant for gas systems, where the compressibility comes into play. In the case of fluid systems, the capacitance is relatively small. So the links, there's one link between two nodes, and within, for devices, single port devices, they're associated with the link. So you can either have a pump on a link, for instance, or you can have a valve on a link, but you can't have both. And you'll see when you look at the GUI as to why that occurs, and how it changes the user interface, the HMI. The relational database is open source, so everybody's got access to it. And in the case of third-party vendors, there's, in my mind, I don't think it's limited. There's control vendors that are interested in animated schematics so that they can validate their control sequences and their control loops. And in the case of control, it's often the case that you'll have control pages that are used by the operational people, and those can be simulated using the animated schematics, where the simulation is playing in the background, and the control, the animated schematics are stimulating the simulation. Then again, the animated schematics companies will be interested in control displays. So I'm sure quite sophisticated control displays are being created by companies like GenLogic, for which I've been working with them in order to create an interface with the MySQL relational database, and that's been successful. And I'm able to give a presentation as to how that works with SCADTS, DTS. And then the instructor. The instructor has in the case of simulators, where however complex they may be, needs access to the state of the system, and being able to control the system by acting on particular elements, particular fields within this relational database. So all information, whether it's instructors, whether it's control vendors, require access to the relational database to get the state of the system. The company GLG, as far as third-party vendors are concerned, provides animated schematics based on MySQL relational database set. Works well with SCADTS DTS, and is interesting how it can be applied for trainers, particularly in the case of power systems, as in the case of aircraft, ships, any type of power system. And as far as the market is concerned, well, I put it down to training, control, design, and the products that included are desktop trainers, simulators, possibility of using this with simulators. So as far as training is concerned, the power systems, fluid systems, aircraft, ships, balance of plant within power plants. Within for control vendors, validate control loops and control sequences. In terms of design, calculating pipe lengths and diameters, validating the system design itself. And as far as the products are concerned, then apart from the simulator itself, SCADTS, we have desktop trainers. So that's it. Our next video will be an example of the use of SCADTS.